So, welcome to episode 2 of Slack Chat. I'm Stuart Winter, the developer and architect for the Slackware ARM port, and we've got Phil, who is the maintainer of and developer of SARPi, which is SARPi stands for Slackware ARM on a Raspberry Pi. So the idea is that you buy a Raspberry Pi and you can easily install Slackware ARM onto it. And we're going to pick up where we left off from episode 1. We'd started on the path of talking about how the open source community interacts, and Phil and I were just talking again before we started recording, and I think, I haven't checked, but I think Phil was about to start talking about what Phil is doing with the SARPi project. It's an extension of my project, which is the Slackware ARM project, which is an extension of Patrick Volkerding's project, which is the Slackware project. And the thing about that is that it's to do with a respect of what you're linking to.
Yes.
We talked about this the other day, didn't we? In the case of the SARPi project, in fact, because it is I don't know any stats. I'm just going based on what I've seen and read. But I know people say at work you have a Raspberry Pi, and what that means is that they've done a really good job at marketing. And so therefore it is possibly the most popular ARM computing device that people can start playing around with, like in a toy sense, or start hacking on, start getting back in touch with computers again, if you know what I mean. But not in a sense you don't need a big fat PC with tons of ISA boards and all that stuff. It's like, hey, here's something smaller that doesn't take up much space, and you can start getting back down to the basics with Linux, because that's where Raspbian is there, right? So it's got that piece. So they've kind of So what the reason I say that is because a lot of the user base, I don't know any numbers, but my perception is that a good percentage of the users of Slackware ARM come through Phil's SARPi project. And so that's the first, depending on the way I looked at when I built Slackware ARM, I think you've asked me this question ages ago, was like, how do I view it? And do I not want to drive people to the project? So well, I don't really mind. I mean, I'm a Slackware x86 user. I just built this thing, and I built Slackware. It happens to run on ARM. So to me, the user base was always going to come from Slackware. If someone happened to be interested in ARM, as I was, there it is. I just put it there because I wanted to do it. I wasn't thinking about building a community around it. Whereas that's kind of you are, and and I guess going back to the original thread was that if you're going to start doing that, you're using someone else's work. Essentially, you're the face of someone else's work. So there has to be a pretty good modicum of back and forth respect about what it is that you're linking to. Was that kind of what you were going down?
Yes. You've just taken away my entire. My entire wording, because you said it all. Yes, it's one of the things that I'm very, very conscious about is the fact that Patrick has a brand. He has a trade, right, and that must be respected. I mean, the laws that govern that dictate that you can't mess around with it and do any negative marketing or anything untoward. So that must be respected by law. And besides that, I feel that a guy who spends most of his life banging away at a keyboard, that work is worth respecting just for the fact that he's done it. It's like you don't go and deface the Mona Lisa or insult the Queen or anything like that, because it's disrespectful. So in that sense, people's work must be recognised and respected, and that in turn goes for you as well, because SARPi wouldn't exist without what you do. If you didn't put all the time and effort into Slackware ARM like you do, we would have nothing to work with. That's kind of what I meant about respect. And there's plenty of people that obviously assume you can take Slackware and do whatever your mind comes up with. But for me, there is a limit, and I've seen, and I'm not going to tell you where, but I've seen a couple of Slackware, and that word I use loosely, images which are horrifying, and I wouldn't ever want to do that. I wouldn't ever want to bring the quality of, or even the name and reputation of Slackware down from the high level at which it is.
Yeah, we've talked about this before, haven't we? I don't on and off, and I think it's
difficult for me because I'm incorporating closed source firmware blobs in order to boot the device, and I have no choice. There is U-boot, which you are more familiar with than me. There is U-boot, which last time I read into it, which I think was about a week ago, it was still not 100% stable. But as soon as that comes into play, I can well imagine moving away from the closed source firmware onto U-boot. You know, that's something that I really am interested in doing. Not because I think it's any better, it will work any better than the Raspberry Pi firmware, but because it's not closed source. You know, and then people will have the option to boot the device how they like. They can even build their own U-boot for that purpose.
So what was the link now? What was the link between the U-boot and the sort of line of respect kind of thing? Did I miss the
fact, the line of respect and U-boot?
Was there no link? Or maybe there wasn't.
Two different conversations. Yeah, the respect is always there, and you know, I realise I'm working with software that's not open source, so it's difficult sometimes to maintain the standards.
Okay, you come from that angle. Yeah, I see what you mean. So you kind of saying. I did wonder if that's what you were saying.
It made sense in my head, Stuart. Sorry.
It makes sense to me as well. It does. Well, so what you're saying is that you kind of, in some respects, feel like you're polluting the right. Okay, because you're including this. Yeah. I see what you're saying.
So the absolute necessity to stick to what is Slackware and Slackware ARM becomes even greater because of that. And I don't want, excuse me, I don't want to go down the road of adding things that you don't include in Slackware ARM. I've been asked more times than I can remember to incorporate. I'm trying to think of a specific thing that would horrify me. Or somebody said, can you include screen in the installer? Because I don't want to sit there and watch it installing. And I thought that's the entire purpose of the Slackware installer, because then you see what's going on, you know what's going on. You know.
What? Sorry, is this what? Doesn't make sense. Why would you need to install screen? If you're sitting at it with a virtual console, you press Alt and F1 or F2, or use the Alt and the left and the right arrow keys, and you switch to a different console, and that's it, and you just switch back again.
I think it was for remote purposes. They were wanting to. It was years ago. It was years ago, and I think they were working remotely, installing Slackware, and they wanted to have screens so that they could start a screen session and install Slackware within that screen session.
Well, yeah, but so okay. Well, let's not discuss how to do that. I think one of the interesting. Although it does highlight, I think, just that request does highlight what I think is a lack of, like, understanding of how to do it in a different way, where you don't need screen. For example, if you look at how to do screen, in the installation documents for the boards I support directly, that it suggests you use screen as a serial console.
Yeah.
So you can actually then your screen is either it's either over SSH or it's a USB. Oh no, what do you call it? A serial console. You can use screen anyway, so you can detach it from there. So I think it's better. Anyway, I was interested in one of the other things though. So you brought up. This is one of the great things about I like the way we're doing this podcast. We're just kind of going with it and going into the next, what I think are interesting topics. I think, like, I'd ask you a question. What's the issue of adding in? Let's take screen out. That's a bad example. But what about some other examples? If, for example, just a bit of software, like you asked about, I don't know. Let's say some network configuration software that's not part of Slackware at all. Like, what's the issue with adding that in as a SARPi package?
Right. It stems from when things go wrong, and I can't remember the specific occasions where you've been blamed for my mistakes. But
that's happened a couple of times.
There have been occasions, and it saddens me when I have to face situations like this, because, well, this SARPi isn't anything that encroaches on Slackware ARM. It's just a facilitating way in which to get Slackware ARM onto the Raspberry Pi. It's certainly not an operating system. But when people install it, they think they're installing an operating system. And so I can imagine that that's the reason why you get blamed for things that I broke. And in that vein, it's not always human error. Sometimes it's like the firmware. The firmware has been updated and something stopped working. So you just need to reinstall the firmware with the new stuff. But that is one main reason why I won't include things that aren't absolutely necessary. Wireless networking firmware, yes, because the Raspberry Pi 3 and 4 have the wireless chips on board, so you need it. And that is my limit. And if I start sticking Tom and Jerry packages in there that people have requested, it then becomes something of its own. It
does, yeah.
You know, it's not respectful towards your work, because I'm adding to it and thinking I'm doing better in doing so, which is never the case in my experience. And that's why, you know, I want to work with what you do, and I want it to be as an intact state once it's installed and installing as it is if we weren't using SARPi. It has to be as close to the original as possible, and that's why in the very beginning, me and a mate got together. Al is my mate who started the SARPi project with me, and we decided that there was a couple of images out at the time in like 2012, which was when we realised that Slackware was not being developed for the Raspberry Pi, and we were both real hard, not hardcore. He was a hardcore Slackware user. I just used it, and I used it for about 7 years before the Raspberry Pi came out. Anyway, that's another story. So we decided, because there was little support for Slackware, that it was missing out. And seeing as this Raspberry Pi device was a device primarily designed for educating school children, what better education could you get than Slackware? Well, there isn't one. So why don't we make it happen? Because nobody else looks like they're going to do it, which led me to ask you for help at that time. And then we decided, there was a couple of images out at the time. There was one from Stanley Garvey, and there was another one who's, the guy's name I forget, but I do remember these two images.
Oh, it was David Spencer, wasn't it?
Or was no,
it? Oh, okay.
Dave Spencer. His name is well known at SARPi.
Yeah, I think Dave Spencer, he actually contacted me originally. I think he worked with me originally.
Right.
Not worked with me. I mean, like, we had exchanged of his, yes, I
Well,
can help you do this. For example, so there are some things in Slackware ARM that actually is just for the Raspberry Pi.
yeah,
There are some exceptions and
yeah.
little tweaks and hacks and whatnot in there.
Well, Dave Spencer has a website. Idle. No, that's his GitHub. It's davescollective.co.uk, and he has on there some a set of files, some scripts, and it's called Raspy Slack Build. Now, when we decided that we weren't going to go down the image route and we wanted users to actually install it for themselves, we set about building our own processes in order to do that. And then we came across Dave Spencer's scripts. Now, these scripts were not exactly what we had in mind, but they were quite close. So we decided that we were going to download his work, which was kindly made freely available by Dave. And we started to modify these scripts. And cutting a long story short, is we ended up with the SARPi installer and a set of packages that you can download today. Dave, meaning he, Dave's work has been very inspirational in what we've done, and continues to be to this day. It's amazing how looking at other people's work, and this goes for you too, Stuart, when I look at a script you've done, and I'm thinking, oh, that's how he's done this. I've been having a particular problem with some code or a process or a function or whatever it is, and I'll look at your script, and one recently was the Linux source package, and I went through it and I thought, oh, that's how Stuart's done this, right? Okay, then, and I actually copied your methods in order to produce the Linux sourced package that we distribute on SARPi. So yeah, Dave's done a lot of work, Dave Spencer, and he's got a really juicy firewall, rc.firewall script on his idle mode GitHub site that I think is worth looking into. It's very clever stuff.
Oh, okay. I need to move mine over to the NF tables actually at some point. Yeah.
But yeah, so we decided, me and Al, that we're going to make these poor people that use our software install Slackware the way it's meant to be installed.
Yeah, you mean so when I first built it, I was always thinking, it had to be. Actually, you know what? I find is quite funny is that if Slackware ARM didn't start on the machine it started on, you probably would have never have had to even think about that, because I probably would have just done what everyone else did. Or when everyone else, I mean the other distributions, which is just produce images most of the time. Debian's different actually, but most of the other ones, they've got here's some pre-built image at some point in time, have a nice day, kind of do what you want, which are quite good actually, to be fair. But it's not how Slackware's installed. It never has been. Slackware x86 has never ever given you an image and said stick that on a hard disk. I mean, it's a zip slack or something like that. But that was.
Well, that's another thing about Slackware. And I used to laugh about this in the early days. And I started using Slackware ARM at 2012 is when I first started using it. And I have a Linux server at home, and the number of times I shut the Linux server down because I thought it was a Raspberry Pi, you wouldn't believe, because of the absolute similarity between Slackware x86 and Slackware ARM. And that is all credit to yourself for building it that way. It's absolutely wonderful that you can go from one platform to another. I mean, like with, say, the Mac and Windows, you can install Windows on the Mac and vice versa, but they're not the same. Whereas you get Slackware 64 and you install it on whatever machine, and then you get Slackware ARM and put it on a Raspberry Pi.
Yeah, it's almost the user
Until you
experience
do
is
some
identical.
searching around, you aren't aware which one's which.
No, you wouldn't be. No.
Okay, so you can type uname and use that command to get that information, but it's easy to get if you know which commands to use. But just for general use, if you were browsing the internet on the command line or copying files from one directory to another, you've got absolutely no clue that it's Slackware ARM, because it is so like Slackware x86 that it's unbelievable.
Yeah, I was just thinking about that as you were saying it. I never thought about that dimension before.
Oh.
I was just going to say the reason why that's possible, because it's only me that builds it, right? There's no one else that does any of that stuff. So I think the only way that it's possible is because of the operating system that Patrick builds, but it's not which is done by, it's not one person. He does build it himself, but it's developed by the team. But he's the one that actually builds it all, and so he's the one that does it. So he decides whatever he decides when he does it. So he does that. But the thing is that I guess because he's still one person maintaining it, and I'm one person, it means that it's not like, for example, let's say Fedora. I bet you it would be so much hard work if one person tried to port it and get it all working. But on the other hand, so this is also when you come down to standardizations, because back in the old days when I first started, ARM just wasn't ready. I mean, like there was a separate kernel, completely separate kernel branch, which was maintained by Russell King, who's like the ARM sort of godfather, at least in the Linux world anyway. So that was there, and things like glibc just didn't build at all. I mean, you had to go to Debian to find a patch which hadn't been upstreamed and all sorts of stuff. And so it was very, very difficult to get anything to build. Like, so bar some of the basics like bash and zlib and a few of the like core things, stuff just didn't build at all. Which I think it's quite interesting actually to think about that, because I saw that people turning up started building their version of Slackware ARM, and I thought, God, man, if you only had done this 10 years ago. It's so easy now to build it. But the thing is, that just also goes to show that the software itself has improved. So now, most of Slackware ARM has 0 patches in it. There are virtually no ARM-specific patches. So for years, I used to carry Debian patches, absolutely years. It was only in the hardware floating point port when I rebootstrapped it. I was like, you know what? I'm going to delete all this patch stuff and just find out what happens, because I bet some of it's for. I kind of know what it's for, but I thought, but no one else has it. Why do you use this? Fedora doesn't have it. Arch doesn't have it. Why? What is this thing? And I thought, well, I can't do that in the soft float port, because actually I don't know what I've built into my operating system at this point, right? It could be that I change it. I'm going to back these patches out because I've had enough, and then I go and rebuild it. Everything's fine, and then 3 weeks later, it's not fine.
Yeah.
And because I've had that so many times. I used to have these build servers where I would have like 3 different ARM machines at various different stages of life. And sometimes I'd go back to one that's still got 2 months uptime, and because everything had fallen apart. And this is what happens when you start taking other people's work and their patches and stuff, just because to get it to compile, right? So this was the trap I fell into. I was like, okay, let's just build it, because to be fair, sometimes it's all right, actually. I mean, I take some of the stuff for Firefox, and I don't care what it changes about Firefox. I don't care. But actually, that's not quite true. That's not a bit of a broad sweeping statement. I do care. I'm not going to go and add something that's completely anti-Slackware. For example, putting the Debian logo on it. It's not going to do that. But there are certain other things that enable certain aspects, like certain bits of features inside Firefox. I don't really mind if that differs from Slackware x86, because, like, honestly, that's not Slackware. That's just Firefox. Unless it breaks Firefox's licensing agreement, which I can't imagine it does, then it's like, okay, cool, just leave it. But also, because nothing links to Firefox, it doesn't matter if it goes a little bit crazy and looks a little bit different, because nothing's linking to it at all. It's like a leaf, on the tree. It's not if I change I'm not changing the trunk. So you don't really need to worry about those kinds of things, and it saves me time trying to figure out exactly what is required. But anyway, back to the point. Mostly, you don't need that many patches in ARM anymore, so it's a lot easier to build. But it also goes to show why I think the Slackware ARM can be so similar to x86 is because it's actually the simplicity of Slackware itself. I mean, there's quite a few things in there to make it work on ARM, and it's been a lot of work.
Well,
but
in my experience, Stuart, it's the most portable operating system.
Yeah, it's pretty portable. Yeah,
ever known. I mean,
that's the description.
I've had it on the solid one clear fog, running pods, Pis, and on the Raspberry Pis, and by far easiest is the Raspberry Pi because the firmware is already built for you, but it's absolutely no problem putting it on any other architecture. And that's one thing I love about it. It's, as from a developer's point of view, no, it's not the easiest piece of software in the world to work with, but you get results, and you get results by doing it properly. And when you're working with Slackware, if your code is sometimes a bit sloppy, you are not rewarded. So yeah, it's great for that. It's great that you can just take an OS and the boot firmware and put them together and get a completely working system out of it. In fact, I don't know any other operating system that's so versatile in that way.
No, I don't know. I mean, I think it's more. The thing is, if you look at it from a different angle, there are lots of other distributions. There are a number of other distributions, most of which I would say have a significantly larger selection of packages that you can just install. So you don't have to go and build them. I mean, we've got slackbuilds.org for that, which sort of fills a lot of that gap. But you still have to compile them. But I think that it goes back to what we said on the previous podcast of why do you use Slackware. You're still going to have to make a bit of extra effort, but depending on what you really want, if you want to be able to learn how to use a Unix system, which I suggest, I love it. I absolutely love Unix. I can't tell you how many. I just don't know what it is. I've got my old Unix books. I actually brought them down from the loft. I love. Do you know what it is? I do know what I love about Unix. I love the fact that the people who made it are engineers, and they think like me, and they write like me, and they just put it. That's not trying. It's not. There's a lot of engineers, right? But especially the old stuff. You know what it is actually? That's the stuff that I studied, and I've learned how to write like them. I think that's what it is. But that's what it is. That's what it is. I learned from them, and that's why I like it so much.
It's like I was saying to you the other day. The idea of one man and his keyboard achieving success and getting those results. That's what really rings home with me, because as a kid, I had the ZX81 and the Commodore 64 basic machines, and that's what I did. I just hammered in the code. So yeah, it gives me a lot of respect for somebody who puts in the time and effort in that respect. And Slackware is all about banging on the keys. It's brilliant. In fact, I never, not once, do I use a mouse while building any of the SARPi images or packages. Not once do I use a mouse.
Wow.
Ever have I used
shocking.
The mouse.
I use the mouse all the time, man.
Yeah, but I'm no purist. I'm no Linux royalty observer. But you get it all the time, with like the program I mentioned to the other day, the shell check, and somebody said that you shouldn't really need software like that if you know what you're doing.
Sorry, I don't remember that actually. What was that about?
Shell check. It's a bash code parser, and it's I found it on the Slack build site. And what you do, you build your bash script code, then you run the code through this checker, and it tells you what errors there are or what mistakes you've made. So I thought you were in on that conversation. However, somebody mentioned that you shouldn't need this kind of software if you really know what you're doing, and I just said, well, that no bang. I need something to verify what I've done.
But okay, hang on a minute though. There's some, so I have not. I don't recall that conversation because
Sorry.
otherwise I would have remembered exactly what I just thought. Which there's something. Okay, I've never come across it, so you can fill me in. But what does actually? There are two things here. First of all, you've got an interpreter. So you write a script, you run it, and it doesn't work. You stick at the top of it -x, so bash-x, then it tells you what it's actually executing, and you can go, that's what it is. So the bash is running it like this, and it doesn't work because I forgot to put a variable name in quotes or something like that. And so you do that, and then you debug it that way around. The only concern is if you start doing things like rm-rf / because you've forgotten to put a variable somewhere in the path, or you've just. But I'm not sure. I don't know. Is the thing actually going to be able to evaluate crazy ideas like that just turning up?
Yes. Well, it's a project on GitHub is shell check, and I really don't want to go on about this because it's got absolutely nothing to do with Slackware. But
no, it sounds interesting. I just can't understand because I don't know about it. I can't see a place. I don't understand it.
It's easy. You write out your script like you say, and then you run like shell check name of script, and it will run the shell checker through the script. Yes, I use EOUX in my settings at the top of a bash script.
Let me just try and ask one question though, because there's something I don't really understand. In order to run a bash, in order to want to check your bash script, you have to think it's going to destroy the system. But the likelihood is that it's probably not going to do that unless you've got something in there that's like doing rm-rf or rsyncing something over something else, or moving files around, or reboot, or echoing something into /proc sys and causing a reboot.
Right. Okay.
So what exactly are you going to do to your system? Unless you're running it as root, and so let's say you're not running it as root, then you could. What's it really going to do? It's going to go, oh, I don't really get how it's going to destroy the world. I mean,
I do it as a time-saving measure. I've got 6 different build script hives to take care of, and if I've got to make an adjustment, I run the code through the shell check just to make sure I haven't forgotten double quotes around variables or set one that shouldn't have been set. Other errors that pop up with especially source files. There's a lot of errors in my bash scripts with source files. This shell check keeps telling me that it's not POSIX compliant. So yeah, I run it through that just so that I'm not doing anything with the script. And when the code is at a stage where I'm happy with it and I know it's going to work, then I run it. But until I run it, I want to make sure that all the T's are crossed and the I's are dotted.
Okay.
I guess it's just a different way of working. I know exactly what you're saying, Stuart. What you do is probably the accepted way for many people. I'm mostly self-taught, so my means and methods of getting things done are what I've had to work out myself.
Yeah, I think everyone is though, man. I do hear a lot of people say stuff like that, but you'll find that anyone that does this kind of thing in a community is self-taught. Mm-hmm. You can't do this otherwise. I don't think going to a computer thing is going to come out. It's going to lead you to do this. The thing is, when you're doing something new as well, it's like it's funny. I remember I wanted to get some more RAM in my Acorn A3010. That's what it was, one of those sort of early ARM machines, and it was really expensive, right? This stuff was well expensive, particularly for how old I was. And so I wanted some more RAM in it, and I didn't want to pay. I wanted RAM, but I didn't want to do it myself.
In those days.
Oh God, it was really expensive.
Yeah.
And it was like very little as well, right? It was like 1 megabyte or something. But that was a lot back then. You could do a lot in a megabyte. And so, but the thing is, I didn't want to pull out the computer because I didn't want to break it. And so I paid the sort of computer shop to put it in for me. And then I got to this point where I just had like a surplus of PC hardware. I don't know how I just ended up with all this stuff, friends and things. And so I started just playing around with it, and I didn't really mind if I broke it. And so I got really comfortable with working with machines. because I just thought, oh, okay, you know what? If it breaks, when I was at I was at one company, I accidentally actually caused a power supply to blow up, like literally blow up, because I plugged it. It was set. It could have been shipped from the US, and I didn't
Oh,
realize that
terrible. Yeah,
yeah, and it was actually flagged like a little switch on the reverse of the power supply.
yeah.
And I didn't realize that that existed. I'd never seen it before. And so I plugged it into the wall and it just literally went bang. And all the people in the office, like, they suddenly were like, what is that smell? I'm like, it's just computer just exploded. But,
You can
I learned
cause some inconvenience doing that trick.
yeah. But but yeah, I was just saying that because, it's not, I think you can probably just try things a little bit more. You don't need to be the safety net of a lot of things.
Yeah.
It's like all this pseudo business. You don't need to. I think if you really learn, like for example, like the entire Slackware build system runs as root. No other distribution does that. Basically, they all build as a non-root user, and then they use fake routers or whatever they use, like Debian does, to switch. It's basically cause glibc to pretend that it's
Yeah.
actually the root user, so you can do chown and and actually set its root and whatnot. But one of the things about the Slackware is that you're supposed to run it. I mean, you don't run your desktop station as root, but you do all your admin and things as root. You don't go sudo this, sudo that. You open up a root shell and you get confident learning how the computer works. And that's kind of one of the things. Most of my shells are root shells. And so most people will be like, that's madness. But I did it at Red Hat too. I always had root shells open.
Yeah.
As most of the guys did, all the sysadmins I knew at Red Hat had root shells open. Put it that way. We all did, because you knew what you were doing. You didn't. To be fair, I did do one problem once, and that was accidentally when I pasted. There was something weird happened with a clipboard, and there's two different clipboards in Unix. There's like the one for the middle mouse button, and there's one for the sort of Control V. I don't know how it works, to be honest. I've never.
I never knew that.
Yeah, I don't know if there's really supposed to be, but there definitely is in practice. So I pasted something by accident into a shell that shouldn't have been there, and I had to reboot that machine. So but to be fair, but that's once in a lifetime, a couple of times in a lifetime mistake. It's not like it's that. If you start to pay attention to what you really do and you understand how the system works, you don't really make that many mistakes.
That's the key. The key is being confident with knowledge and experience and applying it to using Slackware, and it does reward you. Which something you said earlier reminded me of a question that I've got for you. Recently, very recently, within the past sort of 5 or 6 months, Slackware ARM seems to have speeded up overnight from normal and what you expect to being absolutely super fast. And we've spoken about it before, and I just wondered if you had any opinions on what's changed to make it more speedy and faster to operate.
I'd love to be able to tell you like a wonderful speech, when you get these product managers, wow, we've made these sweeping improvements throughout the business and we've done it. I haven't done any of those things. Right. The only thing I did do a while ago around Christmas time, no, it wasn't Christmas time. No, it was before Christmas time. Maybe, I don't know. I rebuilt everything with GCC. I rebuilt the entire operating system with GCC 9, but that was ages ago, and I wouldn't have thought it would make that much difference. But other than that, no.
If that's made the difference, was that?
That was the only reason I did that.
Was that early July or mid June to early July 2019?
I don't know.
But yeah, it's fantastic all across the board. You put the command in and it just does it. And it's like, whoa, this is fantastic.
That's good to hear.
It is. Obviously, any computer system, the more RAM you've got, the better. So with the ability to buy a Raspberry Pi 4 with 4 gigs of RAM on it, it really does motor well. And well, this is the beauty of Slackware. Yeah, it's so simple and so powerful at what it does, and it gives you absolute ultimate control over everything, every level. You can put it on anything. I mean, I once told somebody, if they find me an ABI for a burnt slice of toast, I'll put Slackware ARM onto it.
You're a man of great passion in this domain. You remind me of years ago, because I actually wanted to make the Slackware porting project. So I actually had like an alpha machine I got from Red Hat, and I got another one from an HCPA from Red Hat.
Yeah.
and they stopped supporting all that stuff. And so I was like, oh, I could put it. And Suns, I had Suns on there as well. And I used Splack, I think. So spoke
Yeah.
to a few of the guys running that stuff. And yeah, and I got really excited. So actually, the original Slackware ARM build system was to work on different architectures. That's why it's
Yeah.
kind of done the way it is. But you remind me of those days, and I was kind of like, yeah, let's put it on everything. It's nice to see someone else has those things still. Those things stay alive, you know.
Yeah. Not to take anything away from Patrick's work, because that is fantastic, and I've used it since 2004. The Slackware ARM port is 99% of what I use when I'm using Slackware. I do, like I said previously, I do have a Slackware Linux server at home, but that just runs. I was talking to a friend about it the other day, and he actually said, you haven't reinstalled much on that machine, have you? And I think it's 3 times I've reinstalled Slackware since 2004, which is testament to the operating system. And that is wonderful. I mean, you cannot ask for more than that. So stable, so reliable. And that goes to Slackware ARM too, because apart from the ARM bits, which don't exist in x86, it's exactly the same. I've got a Raspberry Pi 1, which has been running for over 7 years. I've hammered it with Slackware ARM, compiling almost constantly, and it's still going. And that's Slackware 42.
Yeah, you know, it's funny because you touched on a few interesting things there. Actually, one of the things that I've done recently, when I decided to bootstrap the, actually no, I might tell you. Probably it's a bit of a weird thing to say, but when I decided to declare that it was Slackware ARM was dead, I was like, really happy. Because I was kind of like, you know what, this is actually a lot of work. Well, I think we should talk about that as a separate podcast. But there's a lot of, in terms of like the work that you do, but it was a lot of work. Because you know, that's quite good. I'm happy about that. And then I actually just started playing around with it, and I started using it just like you were describing, because I hadn't really been using it as such. I mean, I run it on my gateway server at home, so it does like all the email and whatnot. But I hadn't really used it for day-to-day use, and because I had my old build system just idling away, just hadn't switched it off, I started playing around with it. It's like, you know what, I quite like what I've built actually, and I sort of felt a bit heartbroken. I was like, what have I done? I just kind of stopped working on it, and now I'm using it. I actually quite like it. It's really good.
Yeah.
I never really started. I mean, I use x86-64 as my desktop, so I don't really, and I use it as a server, but I go and log in and make it do stuff and run screen. I don't really use it that much. But yeah, so I started using it. I suppose yeah. Then I started thinking, well, I'll just build a hardware floating point. It can't be that difficult, because it's not like the old days where I've got the build system now. I know how to build it. It's all done. I just need to change the compiler flags, right? It's not, and change the toolchain name and a few other things, but it's not like the biggest thing in the world. And then so I started doing that. Anyway, my point was that I started doing that and built all of the build tools, and that became the project rather than Slackware ARM, because I'd already done the port. So I was like, well, let's do that. And in part of doing that is that Slackware ARM will be more stable than it ever used to be, because back in the old days, when the build machines were so slow, and before I got this CC, all I would do is a one-pass build. So meaning that I get the changes that I'd see from Patrick, and then I would build them because it's so slow, but I'll call it built. That's good. Nothing seems to have broken, but that's great. So I would upload it. But the thing about that is that sometimes what I would find is that, you know, I told you before I'd have different servers running at different stages of Slackware ARM, and I would have to go back into them, remember? And the reason for that was because I didn't do a multi-pass build, right? So meaning that, you know, the problems of, say, you change you change a library and something hasn't been rebuilt against it, or so it changes something fundamental about it, and suddenly you come along months later when you upgrade something else, and it's like, hey, the world's just about to explode, boom, and you're like, what the hell happened? Whereas if you do the way that Slackware ARM's built now, it runs on a 3-pass build system, and what that does is it also means that everything in that batch gets rebuilt over and over and over against itself, and it means I don't need to follow what the build order is so much, which is a kind of a bit of a problem because Patrick does it by himself, and it just depended on which. So I used to have to follow it because he put it out and I could read it and see and go and follow the exact order that he did. But then that doesn't really work too well, because it means I need to look at it all the time, because it's just his build list that he's working on. So it's like, if I happen to see it, I see it. If I don't, well, I don't know which order he built them in. So it's like, well, and they can't be doing that anymore. So there's an easier way, is just tell the systems are fast enough, the Orange Pi is fast enough that I can just make it build over and over and over, and I come back on the third pass and go, right, everything built. Whereas I look at the logs for the previous 2 passes, and loads of things failed on the first pass, more of them worked on the second pass, and by the third pass, they're all happy.
Yeah.
It depends on the number. So what that means is that generally everything is good. You're going to start exercising the system a lot more as you're building that. And so you end up, so it means, in Slackware, we don't know what depends on what. You could make a map in real time. You could make a script. We've got scripts. I've written a script that we can use in Slackware to, you run this script, it basically tells you you've broken this package and that package and this package. And so you go and rebuild those at the same time, and then you push them out in the same batch. So that we don't have that sort of dependency, but you can do it in real time by running scripts to figure it out. I mean, it doesn't catch interpreters, but it does catch linked libraries.
Yeah.
So, but anyway, there's a few of the notes and stuff. But anyway, my point is that, yeah, I mean, we talked about hardware earlier, is that the faster the hardware's got, it's been a lot easier to make the distribution and maintain it, because I can just leave things running in the background for a long time now. But,
Well, in terms of time, I don't know, how long is the process? If you were to start the build process for Slackware ARM, what's the total running time of that process?
Trying to think back, you see, it's probably at least a week is my guess, because the thing is, so when I did do it, I had to still rebuild a few things a few times, because sometimes, this is the thing, Slackware wasn't built to be constantly built that way. So Patrick's changed it a bit now, but it wasn't meant to be built that way. So that means that you're going to get these sort of like things that just fall apart the first time. So what I'm saying is, to get it back to where it was, all upgraded with GCC 9, it probably took about a week, maybe more of that, constant building. Of just the system churning through the packages. But I can't remember how many passes I did. But I did it by package series, I think. Yeah, I just did it by package series. But that's not to say what I was saying about. It's not to say that the things in Slackware ARM are broken, that the linked libraries aren't broken, things like that. It's not to say that, because that's not. I check that before I push it out most of the time. But
well, one of the wonderful things about Slackware is it relies on the administrator to know what depends on what. So.
It does, yeah. I mean, I was thinking with this, it's more like
again, with what we said with the learning curve, it forces you to know. You've got no choice but to know, which is a good thing in my book.
So I was just talking more about how the developer point of view, how the system gets built. So it's more like, for example, there shouldn't be, when Slackware ARM, or Slackware, I guess, is pushed out, it should be that all the libraries are linked together. You won't find a missing linked library in a package. That shouldn't happen. But it doesn't mean that the package will. The same package will rebuild. Like, for example, we upgraded Linux doc tools, and that broke. If the output, for example, changes of one of the tools in there, let's say ASCII doc changes or something like that, it could be that another package expected a previous version of that tool, and so it just that build blows up. It doesn't mean that the actual existing package isn't running nice and stable. It just means you can't rebuild it anymore. So you end up with these failed to build from source things, because the world around it changed, and so it will no longer build. So we actually, it's really good. The guys, I think they call it Slackware from scratch, I think, have been really good. I really like that little project.
LFS.
I don't know if it's little or not. I haven't looked at it, but I've only seen what they've been talking about, which is which I think is really cool. Actually, I think it's a really nice thing to be able to contribute back, so that people can work on the system. It makes it easier for me as well. If I don't suddenly something that would have broken, you've already figured out how to make it work. I think that's a great. I really like that kind of contribution. I think that's a really nice way of people working together on something that they're interested in.
Well, that's what it's all about, sharing information, experience, gaining knowledge.
Yeah. I think this is a good position to stop as well. We've almost on an hour, I think. And that concludes episode 2.